packet captures or like Wireshark that you guys could use later on as a demonstration to follow along. Just a little bit about myself, I guess. I'm a freshman. My name is Nicole Wong, so nice to meet you guys. So this is presented proudly with our ACM Live, so we're not using Zoom, which is kind of a break from Zoom, so it's just great. And for those who haven't checked in yet, but the event check-in code is networks, but instead of an E, it's a 3. And for those who are new to ACM, actually, if you guys don't know what the event check-in code is, you guys can basically create an account on ACM UCSD, I believe. And then every time you attend an event, you can check in and you kind of get like exponent points, I guess. Okay, so I'll just get started. Okay, so today's agenda, basically, I'm going to cover the overarching question of like, what is network security? And then I'm going to go into network fundamentals. So I'll be explaining network models, which are basically conceptual designs of how a computer network is supposed to operate. So how you deliver packets from one host to another. And then I'll be going over 2 core tools. The first one is a graphical user interface version, which is Wireshark. And then the second one is a command line version, which is TCP dump. So I will do a demonstration on those. And for those of you who have like virtual machines or you have Wireshark on your computer, you guys can follow along with the packet captures. Okay, so what is network security, right? So we live basically in an age of technology. We have computers that run applications, right? We're able to communicate and provide services. And we have all these benefits. We have email, cloud computing. We have access to web content. Especially cloud computing is a really big thing now with cloud computing security. So if you guys are also interested in that area or want a workshop on that, you guys can just like shoot it in the chat. However, the downside to all of this is that the internet makes information publicly available to everyone, and network security must be placed to keep all of this like confidential. So basically, network security, if you see on the slide, securing against the compromises to the underlying network architecture, right? You're stopping threats from entering and spreading on your system. So an example would be having a firewall to filter the inbound and outbound traffic of your network. Going over different approaches to security. So there's an approach called the defense in depth principle. I could give you guys an example, which is an oversimplified example, actually. So let's say you have a firewall, right? And then behind it, you have an email scanning service. And then you have finally your workstation, and your workstation has an antivirus software, right? The idea behind defense in depth is that even if one line of like defense is breached, right, you still have others behind it to make sure that your data stays confidential. So the key takeaway here is that don't rely on just the firewall. That's literally just supposed to be on the edge of the network. It's like the first line of defense. And because it's like the first line of defense, a lot of like hackers will target firewalls and just bypass firewall rules. So if you guys have heard of like the CIA triad or the AAA, those are kind of the goals of network security. So for example, the CIA triad would be confidentiality, integrity, availability. AAA is authentication, authorization, accounting. Achieving network security. This topic is really broad, and there's a lot of ways that you could achieve network security, but I'll just go over 3 mechanisms. And the first one is encipherment, which is basically the idea of data confidentiality, right? It's making sure that the data that you have is in a non-readable form for people that are not supposed to be accessing that material, right? So an example, you could be using an encryption, a decryption algorithm with a secret key. Another mechanism is implementing access controls. So I don't know if you guys have heard of it, but it's basically making sure that only users that are supposed to like have control enter the system. So in a sense, it's identification and authentication of an identity. So the concept of least privilege, making sure that users only have granular control and should only be authorized to perform perform the task within the scope of their position, right? So I can give you guys a recommendation. Like if you're assigning rights to individual accounts, I think it would be better to group them into groups and then assign rights to the group of the account rather than to individual accounts, right? And then another way for network security is using a VPN or a virtual private network, right? If you plan on allowing an end user access from a potentially like insecure location to access data on your network, you might want to consider using a VPN, because a VPN provides secure communication over an insecure public network. So those of you guys using or staying at home, like, you know, remote right now, I'm pretty sure you guys use like UCSC's VPN, right? To access like their library or their books. So VPN allows all this data between like the laptop and the remote network to be tunneled, and therefore the data there is encrypted and your IP address is hidden. Sorry, let me check the public chat. Okay. All right, data transmission. So every network device has what's called a network interface card, or NIC, right? And what it does is it makes it possible to connect your device to a network. So a network interface card, I listed here examples like the electrical currents, pulses of light, radio waves. So depending on the medium used to transmit the signal, like for example, if you're using like an unshielded twisted pair, right? The NIC will transform the data basically into electrical currents. And then if you're using fiber optics, then it will transform it into pulses of light. And then radio waves obviously is going to be wireless. So it's similar to an envelope in that it's an analogy. So for example, when you have an envelope, right, you have the actual content of your actual content, right? So your letter, and then you put it inside an envelope, right? Inside the envelope, you like stamp it, you put the stamp, you put your address, and finally you send it off, right? So in this sense, it's similar to how data is packaged, right? Data, there's a source and destination address that's added, and then it's sent off, right? So this is just a high level overview. So actually, depending on the types of address info we are fixing, there are different headers and trailers that are used. And this is just so you guys can understand how data is packaged and not just like think that, oh, you're sending an email, oh, that email just arrives. Why does it arrive? How does the data actually get packetized and how it's sent over the network? Okay. This is kind of like a visual for those who have seen or heard of IPv4 or IPv6 and MAC addresses, but don't really like know the difference. So IPv4 over here, which is an example, is 192.168.12.0. So IPv4 uses 32-bit and dotted decimal notation. This is like the one that we're most used to, I guess. And then IPv6 is 128 bits, and it's in hexadecimal notation. So 2001, and it's denoted by colons. So colon and then DB8:0:23. So your MAC address, also known as media access control address, is also your internet address. So every network interface card has what's called a hardware address. And this is called the MAC address, right? MAC addresses look something like this. It's also denoted by colons. Okay, so just to start off, I don't really use polls, but this is like one of the few polls that I do have. How many of you guys know what the OSI model or TCP/IP model is, or have like heard of it before? Okay, it seems seems like some of you guys have said yes, some of you guys in the middle, and then most of you guys are nah. Okay, I'll go over those right now. So the OSI model and the TCP/IP model, basically the network industry as a whole has adopted what's called network frameworks to kind of allow designers to understand and maintain kind of like the network. So it's a conceptual design of how data travels from host A to host B. And two dominant or generally accepted models are the OSI, which is the Open Systems Interconnection Model, and the TCP/IP model, which is better known as like the Internet model, if you guys have heard of it, for those who have heard of it. And they're just basically standards that make networks work and how communication basically is facilitated across networks. So the reason why they're broken down into layers is because that it gives network analysts or those who are working in the network industry field a breakdown, so that when people talk in terms of layers, they'll talk like, for example, oh, I have a problem on layer 2, or I have a problem on layer 3. It's a standardized model. So when people say, oh, I have a problem layer 2, you know right away that we have a problem on the data link layer. And that way, it's kind of having the same language when talking about the network as a whole. And understanding, I know it can be a little boring, but understanding the OSI model and the TCP/IP model is really crucial, and it's a critical building block for understanding how networking. So before like going into like Wireshark or analyzing packets, you have to understand kind of like the fundamentals of networking before moving on. And the way I remember like this 7-layer stack thing is I go like all people seem to need data processing. That's the one that stuck with me. But I've heard like ones before, like all people sleeping through networking don't pass or something like that. So like find one that sticks with you and then like use it to memorize it, I guess, in a sense. And then the TCP/IP model here is a 4-layer. So I really like this visual because you can kind of see how they differ and how like the TCP/IP model will kind of like group the application, presentation, session into like one. It's called application, and then it will group like data link and physical into network access. But like nowadays, they don't use like this in a raw form. Like there's like a hybrid version where like layers 1 to 4, like for physical data link, network, transport, those are considered like your lower level layers, right? So they're considered like transport layers or data flow layers. And then you have 5, 6, 7, which is session, presentation, application. Those are considered like your upper layers. So we can just refer to them as like your application layers. I'll go over protocols in another slide, so we can just leave this here. But they are like examples. Like I'm pretty sure you've all heard of like HTTP, right? Hypertext Transfer Protocol. That is a higher level protocol because it has to do with sending data from your client and then receiving it on or requesting data from your client to the server. So the client server model. Okay, so this is another visual for the OSI model, which I like too. So for this OSI model, you can see kind of the breakdown of the applications and then its role. So I didn't really get into the explaining the roles because that can take like a little longer, and I do want to make this workshop not as long. But over here, you guys can see a brief summarization of what happens in each layer. Basically, the bottom layers have to do with like physically sending the data over, while like the top layers have to do with like what you see when you receive the data. Over here, oh, I do want to note the package data unit, this column that you see right here, right? You see how it's called data, segment, packet, frame, bits. So it does, the name does change as you go through the layers. So like when you refer to data in the physical layer, you refer to as bits, right? Zeros and ones. When you refer to the data link layer, you refer to it as a frame. So just a brief summary, I guess, over this, it's a good idea to memorize some common port numbers. You see this over here, transport layer, it says a port number, right? So there are certain port numbers that kind of relate to a specific protocol. For example, port 80, I'm pretty sure you've heard that it's like HTTP. It's not always port 80, but usually it's port 80. And then you have like DNS server, your domain name service, which basically resolves IP addresses to host names. And that's usually 53. And then 20 and 21 is usually the file transfer protocol, which is FTP. And then over here, ARP, which stands for Address Resolution Protocol. You see how it sits between layer 2 and layer 3, and it doesn't have like a specific layer that it sits in between? That's because the Address Resolution Protocol uses the MAC address of your destination machine rather than the IP address, and it provides IP address to MAC address resolution, so going up the layer. This is a lot of information to absorb, but I can give you guys like a big picture, right? It's basically if you want to send an email to like your friend per se, right? You send an email, right? If you send an email, you start from the application layer and then your data gets packetized down, okay? So you send your email on, let's say you use Hotmail or Gmail, right? It's through the application and then your data goes down the layer, right? When your friend receives the email, right, it goes back up the layer. So the data that was sent over like the wire or your Ethernet, right, sent in zeros and ones, right, it goes back up the layer finally to application where the receiver is able to see the email that you sent them. So that's kind of like a big picture overview. I know it doesn't cover everything, but it will help like people kind of understand. Oh, sorry, I didn't look at the comments, but there was a question, what do you mean by going up a layer in terms of numbers? So I don't know if I'm answering your question, but the layers usually are referred to in the industry by their numbers. So when I say layer like 7, right, I'll be referring to the application layer, but I won't be saying like the application layer itself. So it's better to kind of understand which number corresponds to which layer name, in a sense. Does that answer the question? I'm not really sure if that was the question. All right. Okay, network protocols. Those were like the things that you saw in between, right? So network protocols, you can think of protocols as a set of rules that enable the communication to actually happen, okay? So then a protocol suite would actually be a group of interrelated protocols that are necessary to perform that communication function. Yeah, thank you, Chris, for answering the question. So for network protocols, right, in this picture, right, you see this is the TCP IP suite kind of protocol, right? TCP IP suite is an open standard, so it means that any vendor can actually implement these protocols. So over here you see HTTP, which stands for Hypertext Transfer Protocol, and it's an application protocol. So remember, application in the OSI model would be layer 7. Okay, so it's the highest, higher level protocol. And then, so going back, HTTP is the way that a web server and a web client actually interact, right? So it's what's called the client server model. It also does extra stuff. So like it does like define like the content that's sent and the formatting of certain requests and responses. Going down, the transport layer is TCP. So TCP is a transport protocol, the other one being UDP, user datagram protocol, and it manages the individual conversations. And in this case, if you guys remember, the PDU or the packet data unit would be called a segment in this layer, right? It controls the size and the rate at which messages are actually exchanged from like host A to like host B. IP, which stands for Internet Protocol, is in charge of taking the formatted segments from the TCP and encapsulating them. So basically, when you encapsulate them, you assign them destination addresses, and then you finally deliver them, and they become what's called a packet. I don't know if this is confusing or not, but you have to remember what these PDUs are called in each layer. And then finally, you have Ethernet. So Ethernet would be your physical layer or the network access layer. It's communication over a data link and the actual physical transmission of data. So in this case, it will be bits, so zeros and ones. So this picture actually shows the TCP and IP suite that I talked about, which is open vendor, which means anyone can, it's standardized and anyone can use it. But there are examples of proprietary ones. So it means controlled by one vendor. And an example I can give you is, on the top of my head right now, is Novel Netware, I believe, is a proprietary standard. Okay. So this was like a pretty fast or pretty quick run down through important concepts in networking. So I do want to explain why it's important, right? You need a common language basically to describe network functions and capabilities, right? For example, if you're speaking in different languages and you don't really understand like their set vocabulary, it's kind of hard to discuss the issues across the network. So understanding models that are established in the networking industry is a foundational skill. And protocols are a necessary component basically for effective communication, right? They're the rules that are set in place to facilitate interoperability. And you should basically have a clear understanding of a packet or data and what happens as it passes through each layer. And then I wrote just because and understanding what's really going on in the internet, because for example, for vulnerability, there's a lot of vulnerabilities that can happen, right? But for example, if you're using like a network analysis tool, right, you can find transfers that are actually done in plain text, right? So the intruder can actually read the data packets and find, like, for example, your password or like your username, because these transfers are done in plain text. And another vulnerability would be like session hijacking, which happens because there's weak authentication between like the client and the web server during the initialization. The IP layer is also really susceptible to many vulnerabilities, including like IP spoofing attacks. There's a lot of attacks that you guys can look into, but those are just the ones that I have like at the top of my head right now. So okay, this is like another check-in poll, kind of how you guys feeling so far? Is this information kind of like too much, or like, yeah, you'll manage? Okay, cool. You'll manage. That's great. Okay, yeah. Well, if you guys do plan on like going into network analysis, like this specific facet of like cyber, or like you want to become like a professional or like network analysis person, then you guys could look into it more. This is just like an introductory course, so I did give a high-level overview.
Call from Tyson,
Oh, I'm so sorry. There's like a phone. Okay. Okay, so now I'm going to go into network analysis, right? So what is network analysis, right? Network analysis basically offers an insight into network communications that you can use to identify performance problems, you can locate security breaches, and you can kind of analyze application behavior. And the reason why I went over all that kind of like boring but crucial topic beforehand was because to understand and troubleshoot like network issues and actually use the tools, you should have a solid understanding of the TCP/IP communications, or understanding like the OSI model. And people who want to get into like network analysis should usually have a comfort using Wireshark, and I will go over like basic interfaces for Wireshark. And then finally, you have to kind of have a familiarity, I guess, with packet structures and like the typical packet flows. So talking about internet, like network communications, right? There are many examples I could give. Like, for example, you have a web client, right? Which is basically your browser when you open like Google Chrome or Internet Explorer, and you want to request something from the web server. That's a type of communication, right? Or a web application to its backend database, or maybe let's say a DNS client to its DNS server, or like your client or your workstation to a file or print server, right? So those are just like many examples of how data is flowed between, like, let's say host A to host B, right? So going over what is a protocol analyzer, right? The reason why I want to go over this is because Wireshark is what's known as a protocol analyzer. And why it's really useful is because it's able to kind of dissect the zeros and ones on the network, so the bits, and actually break it down and interpret it in terms of like the higher layer protocol. So like it understands HTTP, as you see here, secure socket layer, SSL, and the DNS, TLS, right? So popular protocol analyzers obviously would be Wireshark, which is the graphical user interface version. TCP dump, which I will demonstrate, is a command line, and it's built into Linux, so it's really great. But it's more of a packet sniffer because it doesn't give as specific information. And then T-Shark is the command line version of Wireshark. So in case you want to use like scripting, or you have a huge volume of data, or you want to automate your tasks for data analysis, T-Shark is a great tool to use. So the command line version of it. Okay, so I'm actually going to demonstrate TCP dump here. So if you guys have a virtual, machine, you might want to pop that up, or if you guys have like a Linux terminal, you might want to pop that up. But I'm going to share my screen right now. So give me a second. Let me check the chat really quickly, if you guys. Oh, so yeah, your virtual environment. So I was gonna talk. Did I say something else? I'm sorry. So your virtual environment, right? So I'm using VirtualBox here because I'm running on my Mac. But if you guys want to download a virtual machine, there are types. So there's VMware and VirtualBox. I use both of them. I'm sorry if I messed up like the wording there, because I use VMware a lot because I competed in Cyber Patriot in high school. But I'm using VirtualBox right now. But if you guys want to download that, it's actually very good to have kind of like a container so that everything you're doing doesn't actually infect your host machine. And then I can't see your chats for now because I'm going to enlarge my screen, so I don't have two screens open. But for now, okay. So from here, open a terminal, right? I just want root access, so I just switched to my user. So TCP dump, right? I do want to talk a little bit about TCP dump here. So TCP dump, I would say, is a very good tool because it's lightweight and it's easy to use, right? You can actually do filtering just like you would on Wireshark, and you can analyze like packets using the command line, and it's actually built into Kali in this case. I'm pretty sure other Linux distributions have it too, but because you're bound to see it around, I would say at least understand like the basics of using TCP dump. But before like actually talking or using TCP dump, I do want to give you guys some commands, I guess, on how to like survey the landscape, right? So in this sense, if you do like penetration testing, right, it'll be called like your reconnaissance stage. So the first thing I want to do is what's called IP address, right? And so IP address will give you a list of local interfaces on your host, right? So when you're capturing traffic over the internet, it's very, or on your system, it's very easy to kind of like capture everything on your system, right? But if you want to capture specific traffic over like one connection, you need to know like your IP address, right? So over here, the first one you see is called LO, and it stands for, it's like your loopback address. And basically it's the address right now. I'm just gonna say it's the address if you want to talk to yourself, I guess. And then ETH0 is the one I'm going to be, is my IP address. So in this case, this is my IPv4 network, right? I didn't go into subnets, but this is over the
Nicole,
24.
we're seeing your slides right now. We're not seeing
really?
your VM.
Oh. Whoops, technical difficulties. Okay, thank you for telling me. I didn't know that. All right. Do you guys see my screen now?
Yes, you're good now.
Okay, cool. All right. Okay, cool. So, okay, so now you guys can actually see it, but I did type in IP address.
It switched back.
Just switch back? Oh,
Yeah.
I think I know why. Okay. It's because I switched to full screen on my computer. It's okay. I'll just do side by side then. All right. I'll just do it on the side. I won't zoom in. So over here you see IP address, right, which is the command that I typed in. And then you see LO, which basically is your loopback address. It's the address you want if you want to talk to yourself, right? And then you see ETH0. This is my address here on this specific host system. So 192.168.0.11144 is my net IPv4 address, and then this is my, with the subnet 24 is going to be my IPv4 network, right? So another command that will give you like similar information is ifconfig, but I don't use ifconfig. It's like literally the same information, kind of. All right. So the next one I'm going to show you guys is called trace route. So if you do trace route, right, and then you give a flag of D, which is basically socket level debugging, and then you do 8.8.8.8. 8.8.8, just as a reference, right, is one of Google's DNS servers. So I'm just going to use trace route to make sure that my target IP address is actually reachable via the expected interface. Okay, so this is what you see. Let me just clear this screen here. All right, with share screen, I can't really scroll up, so I'm just gonna type it here again. All right, okay, so this is what you guys see, right? If I bring this back up. So I actually forgot to, I skipped over this, but IP route will give you networks that you're directly connected to, and basically the interfaces and the gateways that you're connected to. So over here is your default gateway, right? 192.168.0.1. I wanted to make sure with traceroute that I was actually reachable within that. So yes, I am. So that's good. So that basically sets it all up, right? So now I'm actually going to use TCP dump to generate traffic, right? So with TCP dump, let's say, okay, you know what? I'm just gonna do this TCP dump, right? I run TCP dump, right? Right now, I don't think there's anything happening, so it's trying to pick up stuff, but there's nothing. So I'm going to switch to another terminal. You can open another terminal, and then I'm just going to send a ping. So I'll send 3 packets to 8.8.8, right? So ping is a simple packet, or it's a simple signal, and it uses the Internet Control Message Protocol, and it's basically really simple. It sends an ICMP request, and then expects a reply back. So I just want to use this to generate like traffic, right? So 3 packets, and then the C flag right here that you see is just I'm sending 3 packets over. Ooh, okay. So this is like the traffic that you'll see generated, right? So this is like a lot, right? That's because I can actually filter filter this. So let me do Command C. Oh, it's really hard to see. Hold on. I'm gonna stop sharing for a second because I can't scroll up when I'm sharing one screen with like, it's like a minimized like side screen, so it's really hard to see. So give me a second. Okay, so sorry about that. So TCP, right, it's picking up the traffic, right? And we see like a lot of things right here. I know that, whoops, I was pressing a lot of keys earlier, so it did pick up stuff. But over here, like in ADDR ARPA, I know that's kind of like a dead giveaway that's trying to resolve like host names, right? Because I didn't set any like flag or anything, right? Okay, so now what I want to do is I want to do TCP dump again, but this time I'm going to set a flag called -n, which is basically no name resolution, because I don't want to wait while like the tool actually resolves IP address to host names via the domain name service. And this time I actually want to filter for ICMP because I don't want like a bunch of other like traffic. I just want to isolate the ping packets. So I'm going to send 3 ping packets again to 8.8.8.8. Oh my God, I did not run it. Hold on. Okay, see, you see there are a total of 3 packets that were sent, right? You see a request reply, request reply, request reply, and I did send 3 packets. So over here, because I said I filtered it and I said -n, right? I don't want hostname resolution, right? It didn't give me, like, if you saw in the previous command that I ran, TCP dump, right? It actually resolved the IP address to a host name. So it was called like dns.google.com, which I didn't want. I just want 8.8.8.8, which is correct, right? There are other filters that you could use with TCP dump. There's actually a lot of filters that you could use or like find out. Another one would be like N, and then you have UDP, which is user datagram protocol, right? It's the connection list version of like TCP. And then I'm going to do port 53 because I want to isolate for 53. Remember, the port number is a common DNS port, right? And then this time, instead of the ping command, I'm going to do what's called NS lookup to Google. And what NS lookup does, right, is it basically finds an IP address that corresponds to the host. And the reason why I'm like filtering for UDP port 53 is because it uses DNS to resolve like this domain name to find like, the IP address, right? So I ran that. Oh, I'm so sorry. I keep forgetting to run this. I need to run this first and then run this. Okay. So now you see here, right? It generates the traffic. If you guys are stuck on like commands, a cool tool to use is like man, right? And you can man TCP dump, which is basically the manual. And if you man TCP dump, it'll give you information, and you guys can like read through it, find certain flags that you want. Let me just click out of here. And the last thing I'll show you for TCP dump is I'm going to show you that you don't have to do live captures that I was demonstrating here. You can actually kind of like analyze existing PCAPs or files, right? So right now I'm going to use for like suspicious.pcap. But what you do is you do TCP dump, right? And then you do, because I don't like the hostname resolution thing, I'm going to do -r, which is reading the suspicious .pcap, right? I'm going to read that. And it reads the existing packet capture over here, right? So this is how you read it, right? So that's all I'm going to go over for TCP dump. I'm now going to go over into Wireshark, but before that, I'm going to switch back my screen and go over here. So this was just like visual in case my virtual machine decided to crash. So now I'm going to go over Wireshark, right? So Wireshark, like I said before, is a protocol analyzer, and it's a GUI version. So I'm going to demonstrate the basic user interface for Wireshark and how to like find indicators of compromise when you're looking through a packet capture. So some basics before we get into it, right? It was released as the name Ethereal in 1998, but in 2006 they changed the name to Wireshark. And it runs on most operating systems, right? So it runs on Windows, Mac, right? So you can basically use it on any of those operating systems. Okay, disclaimer, I think I mentioned this before, but I recommend whenever you're performing a task to use a virtual machine. Oh, thank you for answering the questions. Okay, so PCAPs, I think I mentioned it before, but they're called packet captures, right? If you see like PCAP NG, it's like the same thing, but it's new generation, so it does have more information, I guess, than like regular PCAPs. But Wireshark opens both of them, and you can use TCP dump on both of them. There's not like much of a difference. I'll actually go over this later. I'll do a demonstration first. I'll come back to actual devices coming back. So I'll skip this poll for now. Actually, no, I'll just do it. How many of you guys are actually ready for a demonstration, even though I kind of already did a demonstration on TCP dump? I'll do it now on Wireshark. All right, okay. Okay, so this is for those who have Wireshark installed and actually have a virtual machine that can follow along. Don't worry if you don't, because I do have like what's called for CloudShark. I'll put that on another slide later, but for those who actually have Wireshark and would like to follow along, I did upload the packet captures into like Google Drive. So using this link, you guys can go to it. By the way, this eye looking thing is not an I, it's a J. I forgot to remove the line. So now it looks like an I, but it's a J. So for those who need it, I'll give like 2 minutes, and then I'll switch it to a slide for those who don't have Wireshark installed but still want to follow along. You guys can use CloudShark. Let me set it up.
Nicole.
Yeah.
So all the packet captures that you have are safe, right? There's no malware in them.
Oh no, they're safe.
Somebody asked.
Oh, somebody else. I'm sorry, I'm not used to looking at.
No worries, I got it for you.
Oh, and then another thing to note, like, I'll show you guys like exporting objects, but usually as long as you don't like export the objects and like save it right onto your computer, it usually won't be infected. But like the ones that I have right now, just to give an insight, I guess, one of them is from Pico CTF 2019. I believe Chris demonstrated it in his previous workshop, but I added that for people who are new to like Wireshark and would like to practice. But there is one for that. And then the other two, I think like basic packet capture and traffic analysis don't. Actually, I'm not sure about traffic analysis. That one might have it. That one's pretty long, but just to be on the safe side, I think. Okay, so for the PCAP file that I'm going to be demonstrating right now is I'm going to demonstrate the basic Wireshark capture, but the basic Wireshark capture and the the traffic analysis, they don't have like flags that indicate that you solved the problem, right? The only suspicious.pcap and the capture.pcap do. So if you want to follow along, you can technically use any packet captures, because I'm going to demonstrate the user interface before I get into like finding the flag in the other two. But yeah. Okay, so for those who don't have Wireshark, okay, there is an alternative, right? That's called CloudShark, and CloudShark is based on an open source tool, the Wireshark that we've been talking about, which is the de facto standard, right? But that being said, it's a collaborative packet analysis tool that's not in the cloud, even though its name suggests it's in the cloud, but it's not in the cloud. But it's for those who don't have Wireshark downloaded. You guys can use it. Okay, so I'm just going to, I should have shared the link into the shared notes, but I'm sorry, it's on the PowerPoint right now. But I'll give like 2 more minutes, I guess, and then I'll switch over to my virtual machine. Recording. Okay, so I'm gonna share my screen. Hopefully this works. This one. All right. Okay, you guys all see my screen. All right. So when you first open up Wireshark, right? Wireshark is pre-built into Kali. That's why I really like Kali, because it has like a bunch of pre-built tools in there. But it does come with Wireshark. And when you open Wireshark, right, the first thing you'll see 3 areas, right? Over here is called your capture area, and it's basically all the, oh, sorry, this is your capture area, and this is basically all the interfaces that you have along with a real-time graph of the traffic on that interface. So I want to capture on the E0, but I'm not going to demonstrate a live capture. So I'm just using a pre-saved packet capture, so we don't really need to mine this right now. But over here, you also see a list of recently opened files. So in this case, I did open this before, so I'm going to open the basic Wireshark Capture PNG. And so when you open it, right, the 3 things that you see is 3 panes, right? The first one is called your packet list pane. And then at the very bottom, right, it's just numbering all the packets you have. But if you look on the right side, okay, my screen is like a minimized version, so I can't show you guys, but on the bottom side, it'll have a packet count or the number in the packet count in this specific PCAP. And then over here, you have what's called your packet details pane. So I was talking about how Wireshark is a protocol analyzer, right? And this is the reason why. It can break down into specific layers in the OSI model or the TCP IP model that we talked about earlier, right? For example, if you look at frame, right, this is actually, like, in a sense, it's your physical data. It's basically your metadata. So you can like click on, and then it'll give you more information, right? If you click this one, I am actually going to use this to demonstrate. Okay, so for Ethernet 2, right, you saw Ethernet 2 was your layer 2. So it was the data link layer, right? So if you remember from our OSI model, right, the packet data unit in this is going to be called a frame, right? So Ethernet 2 is just the most commonly used protocol, or like Ethernet, you know, in that specific layer. But there are other ones, like for example, if you were on a wide area network, you would be using PPP, which is point to point. So over here, you have IP and then transmission, and then you have the specific protocol. So basically, Wireshark has dissectors that will be able to make it human readable for you, and that's why a lot of people consider Wireshark to be the de facto standard when using it to analyze. So the first thing I'm going to show you guys is what I typed in here. So this is actually what's called a display filter, and the way it works is like, it's like kind of like Control F if you were in like Microsoft Word, right? It finds like specific packets that you want corresponding to whatever you put, right? So it's a pretty simple one. And for now, the rule of thumb, right, if you want to isolate a specific protocol, just type in the protocol name. So like if I want ARP, I don't know if this traffic has ARP. Okay, it does. So if you type in a specific protocol, it'll just give you the packets related to those protocols. But for now, I'll just demonstrate on HTTP. So for HTTP, right, let me just make this bigger. All right. So over here, HTTP, right, it'll give you the HTTP traffic, right? I was talking earlier, someone asked like if it was like dangerous downloading it, but Wireshark has this cool feature where if you click file and then you click export objects, right, and you click HTTP, right, it'll give you everything, literally everything that like objects such as like pictures, I think videos, maybe pictures or web pages, okay, from like the HTML that you traverse. So let's say a user went to like several pages, right, and you captured their traffic, right? Let's say they click through 4 different URLs, right? Then Wireshark, you'll actually see the actual path and all like the raw HTML or like the actual pictures that were on the website, and you can actually download it and export it outside the PCAP and onto your computer. So, but be aware that if you click Save All, it'll literally download onto your like host machine or whatever computer that you're using. So you do want to be aware of that. I like to use export objects just to see like if there are any like dangerous, like let's say files, right? So that's how you can kind of like look for indicators of compromise. And in this case, I'm just going to demonstrate because this one I know is safe, right? This PNG file. Let's say I save this PNG file, right? And then I save it to, I'll save it to my desktop here. Minimize this. Oh. Okay, so you see that it literally shows you the PNG that that person visited. That picture was located on their website. Okay, so going back here. So the next thing I want to demonstrate or show you guys is the TCP, right? So TCP, I believe I talked about it, right? The transmission control protocol, right? The way it's a connection oriented kind of protocol in the transport layer. And I do want to demonstrate how, if I scroll up, okay, you see this over here, you see the SYN ACK. So TCP has what's called a 3-way handshake, right? So it's so that a connection can be established, right? So it goes SYN, which is synchronized, and then SYN, and then acknowledge the server. You'll see over here the source and destination. So this is your source, so your IP address requesting the IP address of whatever server, right? It's you send a synchronized, and then they acknowledge it, right? And then if they acknowledge it back, you get the acknowledgement. That means your connection was established and a socket is created, right? So over here, get. This is like the first verb of HTTP. So there's like post and get. There's like a bunch of others, but this is the action that you're actually performing. So if you actually right-click this, right, and you do a follow, you can actually follow HTTP streams or TCP streams, which I find really helpful. So I say when in doubt, like just follow the stream, because what it does, it gives you kind of a breakdown. It breaks down. It's specifically tailored if you click HTTP stream to break down HTTP info. So for example, everything in red is what you sent, and then everything is in blue is what you basically received, right? So in this case, you're getting this, right? And then the server responded, gave you a status of 200, which is an HTTP status of okay. So that was okay. And then you see what happened here. It literally gave you raw HTML of whatever web page they visited, right? So this is HTML context that you have here, that you can see here. So an HTTP stream, or a stream in general, is basically a flow of data between like 2 endpoints, right? So you'll actually be able to track the flow. So this following streams are really helpful to kind of understand. And then if you look over here on the left-hand side, you'll see that your display filter is automatically auto-populated, I guess, with the display filter that has it. So it'll be tcp.stream equals 0, right? So let me just exit out of this. So now I want to give you guys a chance to try it. So you guys can either try capture.pcap or you can try the suspicious.png. But those actually have flags. So I want to give you guys around like maybe 5 minutes to do it. I would say do the suspicious.pcap first. So for those who are working on Wireshark, I do have a set of like questions for the specific, whoops. Sorry, my screen, okay. For that specific packet capture, but I do want to give you guys around 5 minutes to try to answer like these 3 questions for suspicious.pcap, and then we'll come back. All right. So going back to this. Right. So I opened the, nope, I did not open it. So let me open it. So I opened the PCAP, suspicious.pcap. This is what you guys were given, right? It's a short and simple packet capture with only 9 packets. And the question was the connection successful or unsuccessful, right? The connection here, the way I would do it, right? You saw like the connection was established, right? This sin, act, right? And then you could get it. That means yes, the connection was successful. That's what I was talking about with the 3-way handshake. But in this case, the TCP or the TCP connection was established, and you as a client could request information from the server. So what is the status code, right? The status code here I was talking about over here. I'll make this easier to follow, but let's remember I say like follow the stream because it's easier to like view, right? If you follow the stream here, you'll see that you sent a get request, right? And then they gave you a status code of 200, right? 200 is being okay, like I talked about, right? Other status code would be like 404, which is like the popular not found error, right? And then the flag here would be 200 IKJ Hagent thing, right? It was obviously in plain text, it was transmitted, so here you could find the flag. So that was the answer to like those 3 questions. It's a pretty simple like question thing, but like I wanted to make sure you guys kind of understood how to navigate Wireshark. It's good practice to play around with Wireshark because the best way to learn Wireshark is just to play around with it. But for those of you who followed a TCP stream, you wouldn't have been able to find the flag, because the difference between the TCP stream and the HTTP stream is that HTTP is tailored for HTTP messages, right? So over here, you see the content encoding. Let me show you the content encoding if you follow HTTP stream, right? Seems like this one doesn't have it, but usually it's, oh, I found it. If it's content encoding, gzip, right? What happens is that TCP stream, right, doesn't actually like return uncompressed data. So it'll return compressed data. So it'll literally give you like the bytes. In some certain cases, maybe you do want to analyze like the bytes rather than the uncompressed version. But in cases when you're analyzing HTTP, the general rule of thumb is to follow the HTTP stream and not the TCP stream. I'm gonna do another poll really quickly. Do you guys want me to demonstrate packet capture, or do you guys want to just move on to other parts? Because I don't know if you guys did packet capture or not. So A being, oh, okay. I'm guessing is A yes or no? I didn't say it was yes or no. So demonstrate. All right, so could someone in the public chat give me like, was that yes or no? I'm sorry, A for packet capture demo. Yeah, was A yes or no? Because I didn't say if A was for anything, and then people started saying A, so I'm kind of confused. Oh, yes, okay. Okay, I'll go over it. It doesn't take too long. It's a pretty simple one that models the idea of the suspicious.pcap. So I'm just going to open it. Okay. Oops, sorry. So over here, this is capture.pcap when you first open it, right? Obviously, it has more packets than suspicious.pcap. So So you're looking through here, right? You see a bunch of ARPs, UDP, TCP. You see TCP, UDP. So the first thing I would do, right? Usually I would follow streams, but I'm just going to use this to actually demonstrate other things that I was going to show you for the user interface. So before actually solving this problem, I want to show you guys what's called statistics. So Wireshark has a bunch of like high-level information that you guys could use, which I think is really important, right? So for example, the high-level statistics, right? It'll give you a protocol hierarchy, right? If you click protocol hierarchy, it'll give you a breakdown of all the protocols that are within this specific PCAP, which I think is really helpful, because if I see anything sketchy, right, or like anything that I want to continue inspecting, what I can do is I can take note of it, or I can literally right-click it and you can apply as a filter, right? So this is also another cool tool of Wireshark, in that you can right-click it and apply it as a filter, apply it as a column, right? So you don't have to actually memorize like all the syntax for certain displays for the display filter. So you can actually apply it and select. So I thought that was really cool. And there are a bunch of other statistics that you could use to do first inspection before actually going and parsing through all the packets. Because sometimes there's like a lot, like over like 40,000 like packets, and you don't want to like sift through all that information. So it's a good idea to kind of get a high level overview of what is in there. But to solve for packet capture, right, what you would do is I would follow the stream. That's what I usually do, right? Because I like to see. So I'm going to go to this time I'm going to go through a UDP stream. Oh dear, I cannot see the bottom. Let me minimize this for a second. Hold on. Okay, I can finally see the bottom. All right. So what I did was I followed the UDP stream, right? Because you could try like to follow TCP streams and HTTP streams, but for now I'm just going to follow the UDP stream, right? You can navigate the streams, right? And then you'll see the display filter auto-populate it, but you can navigate it through, right? And you can find like information. In this specific packet capture, right? If you keep going, you see like something like Pico, right? But if you go to stream 6, you'll see the Pico CTF STAT31355. I just gave you guys the answer here, but if you guys were actually like first time and you guys didn't know like what to do, right? Rule of thumb is I would just, oh, someone asked the colors. Okay, I'll explain it after. But for now, if you guys are stuck and don't know where to start, I would say a general rule of thumb to start is look at the streams or look at like specific statistics to kind of understand what's going on in the packet capture, because there's no one set way of finding like compromises on the system. Another way is also to use the export object that I showed you before to see like if there are any dangerous like pictures. Like for example, I was going to demonstrate the traffic analysis, but I think I'm not going to do that today. But the traffic analysis one had a like it said it had a PNG file, but the magic headers actually denoted it as an MD file, so it wasn't an actual PNG file. So it had the PNG extension, but it was not a PNG file. It was a DOS executable file. So those are kind of things like that you can look for in like a packet capture. Another thing that you could look for in Wireshark are like plain text transfers that I talked about earlier, right? So that's when you see like your username, your password being like exposed, literally plain text. Okay, so for colors for Wireshark, right? So what Wireshark does, like I actually set my colors to be different because I use a different profile, but what Wireshark does, it has like default color schemes. So you can actually change the color scheme. So if you're looking for like certain parts of the packet capture, let's say you want like to mark a certain protocol as like dangerous or something, you can actually do that with the colors because you can change the color scheme. So I was actually going to get into that. It's what's called profiles in Wireshark. They're kind of like preset settings that you want. you constantly use Wireshark, right? So to create a new profile, all you have to do is do file, edit, right? And then if you look at your configuration profiles, right, there's a default profile for Wireshark, right? So profile means all the columns that will be shown, all the colors that will be shown. If you guys use like geographic like indicators in Wireshark, then you can pre-build those too. But for now, like if you are new to Wireshark, I'm pretty sure you opened Wireshark and you had a default profile. I can't show you here because I can't minimize my screen, but on the bottom right corner, there's a link or not a column, a word that says profile, right? And if you click profile, you can actually navigate or switch between your profiles that you want. And to create a new one, right, you just click add, right? And then you can name your profile whatever you want. So like trial profile, right? And then you can click OK. And then you can actually change like the columns. Like for example, let's say I don't want length, right? I can save that, and then the next time I open Wireshark with the profile that I have, I can actually have it already pre-populated. So for example, if I do HTTP, right? Oh, this one doesn't have HTTP. But if I do HTTP here, right, and I have user agent that I want to add as a column. So I right-clicked it and I say apply as column, right? And I want the user agent. Basically, it's the browser used, right? And I want to see what user agent was being used. Like for example, if I see like all or Mozilla, and then suddenly I see like a random like Windows or something like that, right? That can be, or like in this case it's Windows, so that's okay. But if I suddenly like, if it's all constantly Windows and then suddenly there's like one or two that's like Linux or something like that, that can be like a sign that I want to continue like looking into it. So that's another way. But with going back to profiles, like if you want this already set and you don't have to go back and like apply the columns, you can create profiles and save those settings that you have so that the next time you open a packet capture for like a CTF or something, you have columns or settings that you're already familiar with and settings that you want. Another one I like to add is the host one. So I'll apply as column. So okay, the host is in there. It's just this information is really long. So that's all for the demonstration. Let me go back to my screen. Give me 1 second, hold on. Okay, so the slide I'm going to pretty much, end on here, right, is the idea of tapping, right? So tap is called a network test access port, or tap for short, right? And basically how it works in practice, or how we want to intercept data like on a wired network, would be like on a wired network like Ethernet or a fiber cable, right? You have two hosts on opposite sides, right? If you're actually capturing live, like you're intercepting network, what you would do is you would put a tap in the middle between host A and host B. So instead of data flowing like from host A to host B, it's going to be host A to the tap, right? And then tap to host B, right? So all communication that's flowing is captured. And so you place it in line to listen on the traffic, right? I do want to go back to a few slides that I skipped, or that one slide that I skipped earlier, and which basically goes over the devices that are used. So hubs, switches, and routers, right? So hubs are on layer 1, meaning layer 1 is the physical layer, and it's a very, I would say, slightly outdated because switches are like smarter, I guess. But the way a hub works is when it receives a packet, it literally broadcasts it to every interface. So even if the packet wasn't designated to go to that specific host, right, it will broadcast it to everyone. And then if it's not, like, if the host knows that it's not supposed to receive it, it'll just discard the packet. But it's really inefficient in that it's one large collision domain, and that can cause a lot of collisions and problems on the network. So people don't usually use hubs anymore. They use what's called a switch. And switch works on layer 2, which is the data link layer, right? And the way it works is it forwards packets based on the destination MAC address, right? And then it sends traffic only to that specific port. And it sends based on the same like subnet. So if you look at this picture here, right, you see how a switch like will connect like several host machines, and then like you have another switch that connects another set of host machines, right? So this is like one, I guess, like if you were at a, how would I say this, your local area network, right? So then if you move over to routers, which is a layer 3, what it does is it bridges those two separate local area networks together, right? And it uses IP addresses because it's on layer 3, which is your network. Yeah, I believe it's network. And then it forwards based on the destination IP address that's in your header. And it connects the networks together. So for example, if you have an internet at your home network, it will bridge it across from there. That's just a high-level overview. And then firewall and IPS. So that's just firewalls, you know, and intrusion prevention systems. I believe there are many types of firewalls. That's why I said layers 5 to 7. So an example would be a layer 7 firewall, which is a WAF or a web application firewall. And I do believe we have a workshop covering like attacks on like that can actually bypass like web application firewalls. Like there's like cross-site scripting, there's SQL injection, but we have another workshop on that. So I'm gonna go here. Whoops. These were just slides for people if you want to refer to them back, but I took like screenshots in case you want to go back to them, but I did demonstrate those. So this actually concludes the end of this workshop, and more resources. I would say to get better at Wireshark is just to do them. One of the best ones that I like to use, that I use constantly, is called malwaretrafficanalysis.net. And it has a lot of like case scenarios that you could use and actually practice. And then it has write-ups that in case you get stuck or if you really, really can't solve it, it does show you like what it does. And it does like imitate like certain attacks. So I thought that was cool. And for those who want to improve like their, I guess, Linux commands, or like you want to learn how to navigate the system, or you're not familiar with Linux itself, there are this Linux Journey. I like it because it's a really cute interface, but there are other resources out there. And then the next two are just packet capture files that have more information. So that's actually it for this workshop. Thank you guys for coming. If you guys have any more questions or want more information, I guess you guys can shoot a message in the chat. And yep, that's it. Thank you guys.